Did you know that earthworms help plants grow in the ground? Look at this gummy worm. Kind of looks like a real worm, just not the right colors. And one thing we can call an earthworm is nature's plows. They have a big job to do in the soil, and it's really good for plants. Their job is to crawl around in the soil. We see them do it. We've seen them on the playground before in the dirt, and they're crawling around in the soil. Well, that's an important job. That's mixing up the nutrients. That's loosening up the soil so that the roots of plants can start to spread out and grow. And so the roots can take in more water and more nutrients. That's really important. Take a look at these pictures here to see. Here's some earthworms. These look more realistic, the colors that worms really are, not red and yellow like my gummy worm. It says, down in the ground under your feet, thousands of worms wiggle around flower bulbs and tunnel under trees. They twist and turn, eating almost anything in their way. These wiggling worms are at work. Farmers plow the fields to loosen the soil. Crumbly soil lets the roots of plants spread out and grow. Worms also loosen the soil as they wiggle along. They are called nature's plows. Take a look right here. Do you see them doing that? As worms twist and turn, they push aside loose soil. This creates tunnels. Air flows along these tunnels. Rainwater trickles down. Roots drink it up. And moist ground helps plants grow better. So worms are really important in gardening. We want to have worms crawling around in the soil. They're making tunnels for water to get through. They're loosening up the soil so that the roots of plants can spread out. They're helping our plants to grow. So if you see a worm in the soil today in your garden, you can cheer on the worm, say, "Go, worm, go! Keep wiggling, keep loosening up the soil. You are nature's plow. You're helping our plants to grow. Thank you, worms." We are going to use our gummy worms for a science experiment in a little bit. And that science experiment will just be for seeing what happens to gummy worms. But I want you to remember that real worms are really important for gardening and they help our plants grow. All right, let's get working on our fun gummy worm experiment. All right, friends, time to start our science experiment. So we were just learning about wiggly worms that work outside and what real worms do. Now we're going to do a science experiment with the gummy worms. Now this experiment is going to be about osmosis. Can you say that? Osmosis. And that means when water moves in or out of a barrier. So this gummy worm is the barrier. Inside of this gummy worm candy right now, there is sugar, gelatin, and some water. And depending on what kind of water we put this gummy worm into, it's either going to get bigger or smaller because water is going to move out of the gummy worm or move into the gummy worm. So I made some different water solutions here. I made, if you look right here, one that says salt water. So I put a lot of salt in here in this cup of water, and then I heated it up and I mixed it together. I stirred and I stirred and I stirred so that the salt dissolved into the water. That means it mixed in. You can't see little salt chunks, but there's lots of salt in there. So I'm going to put a gummy worm in the salt water. Where do we find salt water in nature? In the ocean. Yep. Sharks, octopus, jellyfish, they all need salt water. Do we drink salt water? No. Sometimes we might gurgle it if we have a sore throat. That means we might put some in our mouth and go, "Ugh," but then we spit it back out. We don't drink salt water, not like animals in the ocean need salt water. we'll see what happens to this gummy worm in the salt water. Now I'm going to take a gummy worm here, and this cup just has regular water. So we'll see if this gummy worm gets bigger or smaller, if water from the cup is going to move into the gummy worm, or if water from inside the gummy worm is going to move out. Put that in there. And then I have a cup over here with sugar water. I did the same thing as I did with the salt water. I put a bunch of sugar in here and some water. I stirred it up, and then I heated it up in the microwave, and I stirred it some more, and I heated it up in the microwave again, and I stirred it some more until all the sugar dissolved in the water. So now this is sugar water. I can't see the sugar particles anymore. They're all dissolved. They're all mixed in the water. Now, sugar water is a great treat for butterflies. If we were at school and we were having our butterflies, I would give them sugar water. That's similar to nectar, and butterflies like to drink sweet things. So I'm going to put this gummy worm in the sugar water, and we'll see if water will move out of the gummy worm or move into the gummy worm. We have to remember that a gummy worm is made out of three things. There's gelatin, sugar, and water. So when we put these gummy worms in the different kinds of water, we're going to have to see what happens to it. Will it dissolve? Will it get bigger? Will parts of it fall off? We'll have to wait and see a little bit, right? Some science experiments happen right away, like when we do baking soda and vinegar, because they don't like each other. But some science experiments take a little bit longer. But we know that a chemical reaction is changing because when it's all done, these gummy worms are going to look different. When I'm looking in them right now, I can see some of the lining of this gummy worm in the salt water is coming off. I don't know if you'll be able to see it through the camera. I wish you were here for me to show you. Can you see some of that floating in the water right there? So that's some of the gelatin that's coming off. So there's something happening there. And if I look at this one, it's harder to see, but there's bubbles along the side of the cup. I don't know if you can really see that. There are bubbles, and one sign of a chemical reaction is if there are bubbles too. You know something's happening. So I will let these gummy worms sit in the water for a while, and we will see what happens. Do you think that they will grow bigger or smaller? Start to make your prediction. What will happen to a gummy worm in salt water, regular water, and sugar? And then we will see in a little bit. Hi friends, so it's a little bit later and we're ready to look at our science experiment now. Now let's remember we're talking about osmosis. Can you say osmosis? That is the process of water moving in and out of a barrier. The barrier in this case being a gummy worm. So some of these gummy worms got bigger with more water in them, and some of the gummy worms got smaller as the water moved out. So let's look at this one here, the salt water. See in here? I'm gonna take out the gummy worm. Let's see if it's bigger or smaller. Oh, look, it got a lot smaller. So in this case, water from inside the gummy worm moved out of the gummy worm. It went into the salt solution. So in osmosis, the plan for the water is that it wants to equal out the same amount of water inside the gummy worm as outside. And since the outside was really, really salty, a lot of the water from inside the gummy worm went out of the gummy worm to make the water less salty and have more water. Let's look at the sugar water. So a gummy worm we know is already made out of water, sugar, and gelatin. And this solution was sugar water. So there's sugar inside the gummy worm and there's sugar outside of the gummy worm. Let's see how the water moved. Whoa, did you see it spill a little bit? My hand displaced the water. And it's slippery. So look at that. This gummy worm is so slippery. And it stayed pretty big. The water in this gummy worm didn't need to leave because there was sugar water inside the gummy worm, since that's what it's made of, and sugar water in the cup. It was about the same. So this gummy worm stayed about the same size. I think it got a lot slipperier though. Sugar. Pretty cool. Now, let's look at the regular water. So, there's just water on the outside of the gummy worm, and inside of the gummy worm there was some water and some sugar and some gelatin. And this gummy worm got really big. Lots of water from outside of the gummy worm came inside of the gummy worm through osmosis. If you were here to feel it, you would feel that it feels really, really full. It's heavier, and I can't really squeeze it now. It's not very squishy because it is full of water to make the inside have more water and for it to match kind of with the outside that had just regular water. So that's pretty cool. The salt worm got smaller because water left it. The sugar worm stayed the same. And the regular water worm got really big. That is osmosis, when water leaves a barrier or comes into a barrier. If you want to try it at your house, you can too, and then you can show me what your worms end up looking like.